Yeah, so good evening, everyone. So today we'll look at this IMO problem from 2018, and this is problem 6. And I'll show you a very simple solution to this problem. So, all right. So this is the problem. It says there's a convex quadrilateral, and it satisfies the product of the opposite sides equal. So ABCD. And so here is the diagram. So it says AB into CD is BC into DA. So this product of these two red lines is equal to the product of two blue lines. There's a point X inside ABCD, such that this X, the angle it makes with this side and the angle it makes with these sides, they are equal, and the angle it makes with this side, they are equal. So these two angles are equal, and these two angles are equal. So what we have to show is that it's the angle BXA plus DXZ is equal to 180 degrees. So basically this angle plus this angle is 180 degrees. So from the first look at this is a very symmetric problem, and the result that we want to show is also a symmetric result, and it's somehow difficult to believe that the problem would be that hard or anything. So so this is what we have to show. Yeah, so let's see what the solution, and the solution is actually quite simple if you use complex numbers. So let's just start. So we choose this point which satisfies this angle as my origin, and I label these four vertices with the complex numbers, so like this. So this is my origin, and I call these four sides as Z1, Z2, Z3, Z4. And for the timing, it's not important whether this point O is, it's whether it's unique or there are multiple points. So if there are multiple points, you can do it one by one, and every time you can change the origin to different points and do the calculations again and again. So let's also label the sides. This is A, B, C, D. It's what is given is that A into C is B into D. And we call this angle as omega 1. This is omega 3. We can call this as omega 2. I have not shown it here, but this is omega 2. This is omega 4. Let's call this length OZ1. This is P. Let's call this one Q. This is R. This is S. So we have all the sides are labeled, all the lengths are labeled, all the angles are labeled. And what we have to show is that omega 1 plus omega 3 is pi. So here you need to know a little bit about the rotation of these vectors in the complex planes. So the rotation of unit vectors. So these are not vectors, but it's in the complex plane. These are called phasors or whatever. But basically, if you have a unit vector, let's say in this direction, and you want to rotate it by an angle alpha to get a unit vector in this direction, you basically multiply it with e to the power minus I alpha, right? So else something like this. So so suppose I want a unit vector in this direction, so that will be z1 minus z2. So that will be a vector which starts from z2 and ends at z1. So the tip is at z1 and tail is at z2. And you want to convert it to a unit vector, so I divide it by its length. So now you have a unit vector here. Multiply with e to the power I alpha, so you get a unit vector in this direction. So that is z1 divided by its length. So that's z1 by p. So similarly, you can do this for all sides. So unit vector here, rotate it with beta, you get a unit vector in the direction z2. So you get this. For this side, you will have this one. For the fourth side, you will have this one. And you can also have this. So you have a unit vector in the direction of z1. You rotate it by omega 1, you get a unit vector in the direction z2, right? So we have z1 by p, that's a unit vector in the direction of OZ1, and you rotate by omega 1, so you multiply this with ei e to the power I omega 1, and you end up with a unit vector in the direction of OZ2. That's Z2 divided by its length. So that's Z2 by Q. So similarly for the all other sides. So this is omega 2. Okay, so I have not labeled it, but as you can see, this is omega 1, this is omega 2, this angle is omega 3, this rotation is omega 4. So for all the angles you can write. So Z2 you rotate it by omega 2, you get Z3. So from Z2 you get Z3. Z3 you rotate by omega 3, you get Z4. And Z4 you rotate by omega 4, you get Z1. So it's from the look of the problem, it's to me it's kind of seems like just by playing around with this I should be able to get the desired result. So let's see the. I think that there are many ways that you can actually show it. I'll just show you one. Okay. So let's say you start with these two relations. So that's this one and this one. So this one sec. Oh, all right. So all right. So you start with this this rotation and this rotation here. So from here, this one I can write Z2 in terms of Z1, right? So e to the power I alpha, I bring it to this side, and basically then you bring Z2 to the other side. And this Z2, I again get it back to Z1 by this rotation here. So this Z2 value I just plug in here, and Z1 will go away, and basically I have this relation. So similarly with the, this, I can do that with this remaining 3 or remaining 6 rotations that I wrote here, and you get a similar result. So we have first we have this, and then with other three set here you get these other rotations. So basically what I have done here is I have removed the complex numbers Z1, Z2, Z3, Z4, and I only have the sides and the angles. Okay, so now I want to get omega 1 plus omega 3. So kind of a natural thing is to just multiply these two, the first and the third term. And you can also multiply this second and the third term. You get omega 2 plus omega 4, but omega 2 plus omega 4 is 2 pi minus omega 1 plus omega 3. So it's natural to sort of multiply these two also. So you multiply these two, first and third, you multiply the second and fourth, and basically you get two equations, which is this. So it's PR and M of this form. So where basically I have written omega 1 plus omega 3 as omega. So omega 2 plus omega 4 would be, it's 2 pi minus omega 1 plus omega 3. So that's 2 pi minus omega. So e to the power minus e to the power I of this. So one of the factors would be 1. So this is, here is a minus sign here. And M equals this, and N equals this. So it's just, I'm just trying to write it in a simple form. So now I just try to play around with this, and you have these two relations. So what I first do is I multiply it with e to the power I alpha everywhere in this, and e to the power I beta everywhere in this, and then I take an imaginary part. So I can skip this M and N, the complicated lengths here, and see what I get. So you take an imaginary part, you get this. You take an imaginary part of this one, you get this. So there's no N here, there's no M here. All right, so this is sine alpha, this will be minus sine alpha here. So, and now I also would like to use the condition that AC equals BD. So I find AC from here, I find BD from there, and then I equate it. So AC I find here, BD I find here, and I equate it, and I get everything in PR and QS. Okay, so this equals this. I bring all the PR terms to one side, and I bring the QS term to the other side, and you end up this. And basically, this I bring it on top, and you apply the sine C plus sine D formula. So yeah, so sine alpha will come this side, sine beta will go this side, and you apply this sine C sine beta plus sine beta minus omega, and you apply this sine C plus sine D formula. You get this, and what does this means? So this means that if cos omega by 2 is not 0, then I can remove this and I get the other part of the equality. Okay, so if this factor is not 0, which is common here, so I can remove that, and then I get this one. All right, so yeah, so this is what we have. We had these two equations, and we deduce that if cos omega by 2 is not equal to 0, then this relation holds. And what exactly do we get if we try to work a little bit more on this? So what I do this time is I take these two equations again, and this time I multiply it with e to the power 2i alpha on this one, e to the power 2i beta on this one. Yeah, okay, so because I would like to remove this ACBD terms. I've already used it, and I would like to see what I get if I have m and n. Okay, so I multiply this with e to the power 2i alpha, and I again take imaginary part. So I get this. I take for this equation I get this, and I take imaginary part. So I have all the sine terms here, and yeah. So now you take the sine double here. Sine 2 theta is 2 sine theta cos theta. So that I apply here on these two, and and what I use is qs sine alpha plus omega by 2 is equal to PR times this, so this factor I already have it here. This I replace it with this one, and so I get basically this, and there is a sine alpha by sine beta term here, so sine alpha will cancel out and sine beta will go on that side. So all this sine alpha, and they will cancel out, and sine beta will take its place. So yeah, so fairly simple calculation. Just do it a little bit more. I write this as sine A plus sine B, and this also I write it as sine A plus sine B formula here. So this is sine A plus sine B plus sine, this is sine A plus B plus sine A minus B. Okay, so here also this is sine A plus B and plus sine A minus B. And this factor 2 will be absorbed inside. So, and this part, they will go away. And what you basically end up is with this here. So m sine beta is PR times this. So this factor goes out here. So this is one relation that we get. Yeah, all right. So again, I put the sine C minus sine D formula, so you get a factor of sine omega 2 out. Yeah, okay. So this relation is all right, and this I can do with the other term also. So I multiply this with e to the power. Yeah, e to the power my 2i beta here, and I can straight away write the result. So m will be replaced with n. Sine beta, beta and alpha will interchange position, and this omega will be minus omega. Yeah, so from the symmetry of the equation, we see that omega will be replaced with minus omega, alpha and beta will interchange places. So I'll basically have this. So m will be replaced with n. Sine beta will be sine alpha. PR will be go to qs. Omega will be minus omega, and this will be minus of this. Beta minus alpha will become alpha minus beta, and minus omega 2 will be plus omega by 2. Okay, so yeah, so you can straight away write this result, but I'll just I just write down all the calculations here so that you can just verify that it's all right. Okay, so this we have. So at the end, we basically have this. So if cos omega by 2 is not equal to 0, then we have these two relations that we derived. And what does it imply? So I basically divide it. Yeah, sine omega by 2 and minus omega 2 by 2, that will go away. And this is like, if this is theta, then this is minus theta. So cosine of that, they will also be gone. So they are equal. And yeah, so what remains is this m by n equals minus PR by QS and sine alpha by sine beta. So m is what? Mn is what? It's a linear combination of the sides. And this is basically a contradiction. Why? Because this side is positive, and here everything is positive, but there's a negative sign here. Okay. So yeah, so this is a contradiction, which basically means that cos omega by 2 has to be 0, and that means omega has to be pi. So alright, so this was a very simple problem, and when it was shown to me, it was people said that this is the hardest I have a problem ever or something like that. So I don't think this is the case. It's the problem is fairly straightforward. Just um, yeah. So what I would really like is that what we did is this transformation with complex number. You try to convert it uh, into geometry. See what exactly is happening in the geometric plane, and yeah. So you do that and see if you can actually find a nice geometric proof for this problem using a similar method. So hope you enjoyed this video, and if you want to write to me, if you have anything to say, you can just email me or you can write in comments. So please, if you like the video, feel free to like, share, subscribe my channel, and thank you for watching, and I'll see you next time. Okay, bye.